Polynomial functions can always be written in the form ax to the n plus bx to the n minus 1, and so on. And the values for the exponents must be positive integers, and then these are just real number coefficients. So the lesson today is to graph polynomial functions, and we are going to start with one that's in factored form. So I'm going to get this out of the way. And if you have a polynomial given to you in factored form like this, then in order to graph it, you just need to find the zeros and make a sign chart. So as you look at this function here, you can find the zeros by just picturing putting in a 0 in for f of x, and then you have each of these factors. And you'll just be looking for the x values that make the polynomial equal to 0. So there are 3 of them, and this is very similar to solving polynomial inequalities that we have done last semester, or last chapter. All right, so we have x equals 0, x equals -2, and x equals +2. And we'll put them on a sign chart. So there's 0, +2, and -2. And then you'll just substitute values into the function to determine whether the output value is positive or negative, same as we did solving inequalities. So don't forget this negative that's in front of here. That's an easy thing to forget as you make your sign chart. So if you say pick +3, then you would get the opposite of 3, and 3 plus 2 squared, and 3 minus 2. And we have a negative, then the +3, then a +5 squared, which is positive, and 3 minus 2 is positive. And the product of a negative and 3 positives would be negative. So for this region we get a negative, and these are our zeros. What that tells us about the graph, the zeros, those are the points that are right here on the x-axis. So you can go ahead and fill them in on your sign chart because they are the zeros of the function. And then we'll test a value in between 0 and 2, which x equals 1 would be a good choice. And if you test x equals 1, you would get a negative for the leading coefficient here, and then a positive when you plug in a 1, and then 1 plus 2 squared is positive, and 1 minus 2 squared is negative. And so the product there would be positive. And if you plug in a -1, you would get a negative for the leading coefficient, a negative for the first factor, a positive for the next factor, and a negative for the next factor. So this would be negative. And then at x equals, say, -3, we'd have a negative for the lead coefficient, a negative for the first factor, a positive for the next factor, and a negative for the last factor. So again, a negative. So what these red values tell us up here, those are the y values on the graph. Okay, so when you go to sketch this, you know that these are the only places where the graph touches the x-axis, and that everywhere else, for any x value greater than 2, the y values are negative. So I know that the curve starts here, and then as you approach 2, you turn to a positive value. The graph becomes positive, and then it comes down towards 0, and at 0 it's positive on the right and negative on the left. And then as you're going to come up to -2, be prepared that you're going to come up and touch at -2 and then come back down again. So it's going to do something about like this. All right, so that's the how to graph a polynomial, and then we are also going to do this other part of the directions. Give the alternate form and state the degree and the leading coefficient. Determine if the function is even, odd, or neither. Find the zeros, make a sign chart, sketch a graph. So we have done the last three. Find the zeros, make a sign chart, sketch a graph. I can already tell that the graph, whether the graph is even, odd, or neither. Take just a minute and see if you can decide. And I'm just looking at the graph and knowing that it has does not have y-axis symmetry, and it does not have point of origin symmetry, so this function is neither. A few of them will be even or odd, and it's good to pay attention to when they are even or odd. Okay, so we'll come back to do the degree and the leading coefficient after we put the function in the alternate form. So I'm going to get this out of my space. And the alternate form, what I mean by that is this function is considered in factored form, and we would like to take that same function and write it in standard form. And mostly I'm asking you to do that because I think that it's good practice for many of you. I don't think it's trivial. It's kind of a pain in the neck because there's a lot of steps, but I think that it's a good skill for you to practice. So I'm going to rearrange the factors. First we can just call that negative x and x minus 2 and x plus 2 quantity squared. You can distribute the x through here, that's fine, but you can't distribute through the x plus 2 factor until you take care of the exponent, because exponents come before multiplication or addition or subtraction even. So I'm going to do this part first, and I'm going to leave the negative x and the x minus 2 for later. So when you square x plus 2, remember that you'll have x squared plus 4x plus 4. And then you need to distribute the x across each of those and the negative 2 across each of those. And the negative x will just wait until later. So x times x squared is x cubed. X times 4x is 4x squared. And x times 4 is 4x. And then the negative 2 is going to multiply all three of these, and I could just keep going across here. Obviously I'm going to run into my graph, so that's not ideal, but also it's sometimes kind of nice to stack them underneath their like term. So I'm going to do that, especially since I'm running out of room. Negative 2 times x squared is negative 2x squared. Negative 2 times 4x is negative 8x. And negative 2 times 4 is negative 8. And then I'll put those together, keeping my negative x out here, and I get x cubed plus 2x squared minus 4x minus 8. And then the last step is to distribute the negative x through. So I get negative x to the 4th minus 2x cubed plus 4x squared plus 8x. And then that would be considered standard form of the polynomial. And when the polynomial is written in standard form, you can identify the degree, which is the highest exponent, and the leading coefficient, which is the number in front of the term with the highest exponent. Okay, so now if the problem had been given to you in standard form, such as this, negative x to the fourth and so on, and you needed to graph it, you would have to change the polynomial to its factored form. So I thought it would be good to show an example of factoring something potentially as complicated as this. So the first thing I would do if you had to factor this polynomial is look for the greatest common factor and take out a negative if the leading coefficient is negative. So I would take out a negative and an x, since every term has an x in it. And then left inside would be x cubed minus 2x squared, plus 2x squared minus 4x minus 8. And then the inside of this can factor by grouping. So I keep the negative x. And then the greatest common factor for x cubed and 2x squared is x squared. And then the greatest common factor for 4 and 8 will be this negative 4. Whatever sign this is will come down. And then you get x plus 2. And then finish off, you get x squared minus 4 times x plus 2. And then notice the x squared minus 4 will factor as a difference of squares. So you get x plus 2, x minus 2. And then you have a negative x and a x plus 2 quantity squared and an x minus 2. Now I kind of like to put the negative all the way out in front, with treating the x as its own factor and the x plus 2 squared and the x minus 2. And then you can see that that was the original problem that we started with. Okay, so last part of this topic is given a graph of a polynomial to try and find the equation of that polynomial. So the key features you want to start looking at are where it crosses the x-axis, or what the zeros are. And since this function has a 0 at 0 and negative 2, I know that it must have a factor of x and a factor of x plus 2. Because I know that I need these zeros. So x equals 0 makes the function 0, and x equals negative 2 makes the function 0. Now, if you tried to do a sign chart for this function, you would need it to be positive, negative, and then stay negative. And the aspect of the equation that makes the equation stay negative, to stay the same sign, is to have a squared on the factor that is at the place where the polynomial turns around and stays the same sign. So since negative 2 is the value of the 0 where the polynomial does not change sign, the x plus 2 is the factor that has to be squared. Now, you could check that on your graphing calculator, and that would be a really good idea. I want this video to not be too long, but if you take this square and put it here and then see what happens to the function would be a good exploration for you. And then this function, see how this little bit here looks like a cubic function? That means that you end up with an x for the x equals 0, 0, and an x plus 2. But if you just graph this function, it would look like a parabola. And what's making it do this little flatten out and come back around is because the function has a cube here on the factor that has this curve to it. So that's kind of nice to know if you have a cubic in your graph and you had to sketch this, that you should make it look like a cubic right near that 0. The other thing that you need to consider when getting the function is whether or not there's a negative in front. And you can tell here that if you substitute in a positive 1, the y values are positive. And so you don't need to have a negative in front because you need this quantity to be positive when you put in a positive 1. And same with this graph. If you put in a positive 1, you need it to be positive. And you could also check if you put in like a negative 3 into this function, it would be a negative times a negative cubed, and that would all work out to be a positive value. And then the last function here, if you had to write this equation, it also has two zeros. One of them is at negative 3 and one of them is at positive 1. And so you can start by saying x plus 3 and x minus 1 to get you the right zeros. One of them is squared, and it has to be this one because that's where the graph turns around. And then because it's going down here, it looks like an upside down x cubed graph, and because when you substitute in, say, a positive 2 or 3 or 4, you need that y value to be negative. That's how you know that the leading coefficient or that the lead factor has to be negative.